In today's video, we're going to go over the distributive property. Like it sounds, we're going to distribute numbers or variables, usually into parentheses with other numbers or variables. For example, if we had 3 times 4 plus 5, you might say that 4 plus 5 could be added first before multiplying, and that is true. So this would equal 3 times 9, which equals 27. When it comes to the distributive property, what we end up doing is distributing the 3 and multiplying it by each component inside the parentheses. Therefore, this would be the equivalent of 3 times 4, 3 multiplied by 4, and we have an addition here, and what that means is that the 5 is actually positive. So we're multiplying here a 3 times the positive 4, we have that. We're going to have a 3 times a positive 5, and we know that's going to be positive, so we can go ahead and make that plus 3 times the 5. 3 times 4 gives us 12, plus 3 times 5, 15, and that equals 27. Sometimes what's in the parentheses cannot be combined like the 4 and 5 just were. Let's say we had x plus 8. Here we know x plus 8, unless we know what the value of x is, we cannot combine it with 8. So our option here is to distribute. We'll multiply the 3 by the x, and also the 3 by the positive 8. This would give us 3x plus 3 times 8. The 3x cannot be simplified any further, so we have 3x here, plus 3 times 8, 24. And that's as far as we can simplify this problem. Sometimes the operation within the parentheses will be subtraction. So let's look at an example of that. Say we have 5 times x minus 2. Like in the previous example, we cannot subtract 2 from x if we don't know the value of x. So instead, we'll be distributing the 5 into the x minus 2. 5 gets multiplied by the x, and then by what's technically a negative 2, because we can think of subtraction as plus negative. Keeping that in mind, 5 times x gives us 5x. Here, we can call it a plus, but remember, this was originally a minus, and now it's a plus negative. And I did that so you can think about 5 being multiplied by a negative number here, in this case, negative 2. So 5 times negative 2. 5x remains the same. And here we have still the plus, and 5 times negative 2 would be negative 10. So we have a plus negative 10 here. Anytime we have that, this is not the most simplified version. So plus negative, we have to realize, is the same thing as subtraction. So the final result should look like 5x minus 10. If the plus negative is a little confusing for you, I suggest leaving this as a minus, keeping in mind that that's going to carry the sign of this number here. So in other words, one more time, we have 5 times x minus 2. That's the original problem. The 5x is the simple part. We know that's going to be just 5x. Here, we have to realize it's a positive 5. There's no negative here. Positive 5 times what really is a minus 2. So as long as we keep our sign straight, we know that 5x is the first portion. Then we have the minus sign in the middle. And then we have 5 times 2, which would be 10. So really, this is technically a negative 10, if we think about it in terms of plus negative, like we did up here. So whichever method is easier for you. I prefer this one. It's a little bit cleaner, but a lot of students that are just starting out with the distributive property may find this one a little more helpful in the beginning. Sometimes the negative value will be the first one that we see within the parentheses. So if we had 5 times and then in parentheses negative 2 plus x, the distribution still works the same way. Here we'll be multiplying a 5, a positive 5, by a negative 2. And that will give us a negative 10. We have a plus sign in the middle. And then the 5 will distribute and multiply by the x, leaving us with 5x. Now normally, we'll want to put this into the proper order. which would be the highest exponential values of the variables, down to the constants. So really, in the end, for a final answer, we would want to rearrange these so the x value comes before the constant. And if we do that, the 5x is a positive. It was plus 5x, so we don't need a negative in front. 5x. And keep in mind, this was a negative 10, so it's going to keep its sign, which in turn turns this into a minus 10. Negative 10 plus 5x is equivalent to 5x minus 10, but this is the more proper form. If we did a nearly identical problem, however, this time, instead of negative 2 plus x, we had a negative 2 minus x, the same rules apply. We're distributing 5 into the negative 2, which gives us negative 10. And then we have a minus sign. And the 5 multiplies by the x here, minus 5x. Again, if it's simpler for you to think about it this way, we could call this a plus negative x. And by doing so, this is now a plus sign. However, 5 gets multiplied by technically a negative x here. So plus a negative 5x. And as we saw a moment ago, we cannot have both signs here. So the result here would look like negative 10 minus 5x. And then rearranging once more into the proper form, the 5x would have to go in front of the negative 10, but it is a minus 5x. So the sign is going to stay with the 5x and create minus 5x. And then we have the minus 10 afterwards. Negative 5x minus 10 would be your final answer. Let's take a look at another example. What if we had negative 2 times x plus y? Well, the same rules are going to apply here. Even though the number in front is a negative, nothing really changes here. We have a negative 2 times an x. That's the first portion of this distribution. And then we'll have a negative 2 times the positive y. Negative 2 times x is simply negative 2x. We do have a plus sign here, so if we want to keep that for now, that's okay. But remember, it is a negative 2 being distributed in here. So the negative 2 multiplies by the y to give us a negative 2y. And like we saw in the last couple of problems, we cannot have the plus negative here. So this would simplify down to negative 2x instead of plus negative. We should recognize that as a minus. And then 2y. Now what if the number that's normally in front of the parentheses is at the end like this? Well, the same rules would apply. We could look at distributing 4 into the leftmost part of this parentheses, which would be the x, and then into the positive 7. This would come out to 4x. We have the plus sign in the middle, and then the 4 times 7. Just to visualize, that would look like 4 times 7. The 4x stays the same, and we have plus 28. And it's in the proper form. This would be our final result. When you have a problem like this, what I suggest doing is taking the number that we're distributing and actually moving it in front. I would rewrite it as 4 times parentheses x plus 7. And we can see by distributing, the 4 multiplies by the x first, and then by the plus 7. That gives us 4x plus 4 times 7, which equals 4x plus 28. Same result, but I think it's easier to distribute from left to right like this. Let's look at 2 more really good examples to really drive this property home. If we have, say, x times 4x plus 5, it may look a little more complicated, but the rules are the same. X first multiplies by the 4x, and then by the positive 5. This would equal x times 4x, and we'll simplify that in a second, plus we have positive x times 5, which would be 5x. In this first part, we should recognize that the x here is like a 1x, and only numbers will multiply with each other, while the same variables, both x's, will multiply with each other. So 1 times 4 gives us 4. X times x gives us x squared. And then we have our plus 5x. Because x squared has a higher power than this x, which is technically to the first power, then we know that we're in the proper format. Even if the coefficient 4 here is less than the 5, it's the power of the exponent that will determine the order. 2 and then 1. In our final example, let's see what happens when 2 gets multiplied by 3 plus x minus y minus z. It may look a little complicated at first, but the same rules apply, and we'll do them one step at a time. We'll want to distribute from left to right, so we'll look at each one individually. The first component in this parentheses is the 3, so the 2 will multiply by the 3 first. This equals 2 times 3. We have a plus. Then 2 multiplies by that positive x, giving us 2x. Next, the 2 is going to multiply into this minus y. So I like to think of this as just keeping the same sign, a minus, and then 2 times y, giving us 2y. And for the last part, we'll use the plus negative version, so you can see that once more. So instead of minus z, we'll call it a plus negative z, which means the plus is our sign here. However, the z is now negative, so 2 is going to multiply by a negative z, and because it's positive times negative, that will give us a negative 2z. Here, the 2 will multiply by the 3 to give us 6. We have plus 2x. That will not change. We have minus 2y, also already simplified. And once more, because we have the plus negative, we need to think of that as just simply subtraction, leaving us with a minus 2z. The only change I would make to this final answer is I would take the 6 and move it somewhere at the end, since the constants will come after the variables. So it could read 2x minus 2y minus 2z, and because this is a positive 6, we would have a plus 6 on the end. So this could now be 2x minus 2y minus 2z, and then because the 6 in front was positive, it would be plus 6 on the end. Thanks for watching. If you found this video helpful, please smash that like button and subscribe for more videos.